reinforced bar is a very useful material to our current world. It is widely used in construction projects as a supporting pillar material along with cement and concrete. So the manufacturing of reinforced bar becomes a very important process in the engineering industry. However, there's a major issue affecting the quality of the rebar, and that is the mill skill formation on the surface of the bar. Now let me introduce myself. Hello, Mr. Jeffrey. My name is Kevin, and my team and I are currently working on a project that is focused on reducing the mill skill formation on the reinforced steel bar. Our solution concentrates on the chemical aspect of the iron material and forms a protective layer of silicon to reduce the oxidizing rate. Now here are the deliverables that we are set up to achieve. They are understanding, observation, ideation, and prototype. I'll explain further as we continue. In this project, we have applied project management process group in order to manage our project in a more systematic way. According to this method, our project has been broken down into 5 parts. They are initiating, planning, executing, controlling and monitoring, and closing. This is the breakdown of the initiating phase. So let me just introduce you what makes us get this idea of getting the reduction of mill skill. First of all, we went to a rebar manufacturing factory and did some understanding and observation phase in the factory. We realized that the production of mill skill is actually the largest associated cost that the factory actually produces. So that's how we get our objective. It is to reduce the mill skill production on the reinforced steel bar. Our goal, we have 2 goals. First of all, reduce the mill skill production by 33% of this original production. Secondly, to show the increment in profit in Teck Sun Ken Private Limited as a proof of our project business value. We also have 2 priorities. First of all, we need to ensure that BV is achieved at the end of the project and ensure that the quality of the rebar is neither downgrades or become hazardous. Here is our 4 stakeholders of our project. Mr. Ng Cho Siu, construction company, rebar manufacturer, and the buyer of mill skill. We will be allocated 500 ringgit Malaysia for prototype and 20% of our associated costs for our actual product. Our product is feasible as the technology and expertise are available. We have been allocated 14 weeks for our project. And this is our complexity analysis. We are categorized under high business complexity. So with all these things listed down, we have drafted out our proposal and pitched it to our supervisor for approval. Now, I'm going to talk about the planning phase. This is the cost estimation details. The silica sand will cost around 6,000, and water and electricity bill is around 3,000 bucks. So in total, we need around 70,000 per year to operate our plant. Right here is the Gantt chart. It can be broken down into 4 major stages. They are conceive, design, implement, and operate. Among these 4 stages, implement stage took the longest duration to complete. And the whole project took around 14 weeks to finish. Next up is the work breakdown structure. It can be split into 2 phases. They are planning and executing, and be further divided into 4 deliverables. They are understanding, observation, ideation, and prototyping. Among these 4 deliverables, there are several tasks that we have to accomplish. And these tasks are divided among all of us to share the workloads together. Each of us have our own tasks to contribute and dedicate into the project. Now, this task is explained in details in the linear responsibility chart. Next up is the executing part. Right. It is focusing on the implement stage of CDIO process, which is building a prototype of our design. We will be developing and building a coating mechanism that integrates into our coating method. Integrate our coating method into this mechanism. Moreover, in the controlling and monitoring stage, we did some lab simulation and field simulation. And here is the data you gather. As you see, both boric acid and silica sand produce positive results in reducing the production of mill skill. But why would we choose silica sand over the boric acid, since boric acid have better performance? This is because boric acid will corrode the rebar and hence downgrade its quality, or silica sands form a protective layer instead. Therefore, we choose silica sand over boric acid.
As a result, our project had achieved all deliverables as stated in the work breakdown structure. My role in this project is quite diverse, as I was playing as a supporting role in every aspect. Let me share with you how I carry out my task in order to achieve the deliverables. In the understanding phase, I was involved in analyzing the challenges of meal-scale production and identified the challenge statement. We did this by gathering all information from the factory owner. And then we found out that meal-scale is causing a lot of waste and loss in profit to the factory revenue, as you can see here. And this is how we identified the challenge statement. Moving on to the observation phase, my team and I constantly visited the factory, and we meet up with the factory owner to gather additional info on the root cause of meal-scale production. After many rounds of discussion and visit, we learned that the high temperature oxidation is the root cause of our challenge, and it is our direction is then set forth. And this is the part where Jishing and I came up with the business value of our project. The result shows that there is a challenge worth solved of 400k ringgit Malaysia. Finally, in ideation and prototyping phase, we organized a few brainstorming sections to generate solution to our project. Once we narrowed down to one solution, we started to calculate all the necessary dimensions for our prototype. And this is the hand sketch of our calculation. It's a bit not clear, but never mind. Afterwards, we built our prototype and conduct lab scales and pilot scale simulation. Here's the result that I showed you before. And this is where I was majorly involved in, is more on the executing part. Lastly, I'm very, very satisfied with the team performance that we all are contributing. Everyone is willing to complete their tasks, although there are so many work interruptions along the way, such as tests, assignment, lab reports, etc., etc. We even help out with each other if any of us require any assistance in our task. Our team performance may be low at the beginning stage of this project, but as we slowly progress, good news came in and boosted our performance. Bad news came in while we stayed optimistic and kept our morale high. And this is how our team performed. However, we did face some issue as well. First of all, we're having difficulty with keeping up our milestone on time as arranged in Gantt chart. This is because we don't actually have a leader or timekeeper roles to keep us motivated and keep things flow naturally. Because we want to keep things flow naturally. That's how this happened. So halfway through the semester, we realized that we are not paying any attention to deadline without someone is there to remind us or motivate us. Therefore, we came up with the mitigation plan, is to appoint Wilson to guide us, and then things started to get on track since then. Secondly, another reason for our procrastination is because the group members are a group of divergent people. We have a lot of ideas in our mind, but we couldn't settle down with a suitable idea. This ideation process took us more than 2 weeks to get it, and it's finally being resolved because Max steps in and converged our idea, and the project has been going on very well since then. So in conclusion, I'm very satisfied with my team. We really did a very excellent job in managing this project. It has been a wonderful experience working with them, and I would love to bring this experience to my future project. I hope that we can close this project and successfully pass it out to our stakeholders. Thank you very much for your attention.